Standard 7th subject Maths Semi-Medium Lesson number 7 Positive Integers. Today we have to learn the positive integers, the facts, the information about the positive integers. How is they? Okay, and you have to keep your notebook and point them the points in your notebook.
Welcome everyone. So, what are integers? We start learning integers with the help of these colors. Now I ask you how many colors you can see. Of course, you can see 4 colors. How do you know that? You counted the number of colors as 1, 2, 3, 4. So you see, we have used these numbers for counting. You use 1, 2, 3, 4 while counting. So I can say that we use these numbers while counting. These numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and so on. These are the numbers which help us while counting. So look around you. You will find so many things, and if you count them, you will use these numbers. So these numbers help us while counting in our daily life. Now what I do is, next thing I will do is, I will put negative sign to all these numbers, and I will get this list. You see, I have put negative to 1, I have put negative to 2, and I have put negative sign to 3, and I will get a new list of numbers. This list of numbers is -1, -2, -3, -4, -5, -6, -7 and so on. This is a new list of numbers. Now I have one more number which is very special number. You see, 0. Now what I will do next is, I will write all these numbers in a single list. You see, and I will get a new list of numbers as this. You see, I have written all these numbers in a single list. Now how did I write this? I have written -1 here, -1, -2, -2. I have written these negative numbers in opposite direction. So you see, -1, -2, -3, -4, -5 and so on. And I have written 0 here. You see, and I have written these numbers which are used while counting here. You see, 1, 1, 2, 2, 3, 3. So now the question is, what are integers? So all these numbers are integers. How did we get these numbers? You see, again I repeat, these are the numbers which are used for counting. These are 1, 2, 3, 4, 5 and so on. And if I put negative sign to all these numbers, then I will get a new list of numbers, -1, -2, -3, -4, -5 and so on. And I have one more number which is 0, and I have written all these numbers in a single list. So all these numbers now in the new list are integers. Now I can define what are integers as number 0 and numbers used for counting. These are the numbers used for counting. You see here. And negative of numbers used for counting. This is negative of numbers used for counting. You see, I have put negative sign to all these numbers which are used for counting. Okay, and that's how we get integers. Now we will take few examples of integers, or I can say that we will check so many numbers if they are integers or not. You see, the first number is 0. You see, we have 0 in this list, and we know that all these numbers are integer. So 0 is also an integer. We take it right. It means this is an integer. You see 5. 5 is used for counting. This number is used while counting. So this is also an integer. Now you see 67. This number is also used while counting. If you count as 1, 2, 3, 4, 5, 6 and so on, you will get this number. So this is used in counting. So this is an integer number. Now we see minus 8. You see, this is minus 8. This is the negative of the number which is used for counting. You see, minus 8. You see, now it is only 8. This is a number which is used for counting. Now if I put negative sign to it, it becomes minus 8. And that's why it is an integer. Now you see 2.5. You can see that there is a point in this number, and the numbers with the point are not in the integers. So this is not an integer. Numbers with the point are not integers. You must remember this. The new number is 8 by 7. Oh, sorry, I have crossed it. This is not an integer. You see, this is not an integer. I have crossed it. Now a new number is 8 by 7. This number is not included in integers. So it is not an integer. You don't use it while counting. You don't say 8 by 7 while counting. So this is not an integer. And we also don't use 2.5 while counting. You don't say 1, 2, 2.5, 3. We say 1, 2, 3. And we don't use this number. So these two numbers are not integers. Now we see minus 90. You put your finger here. We see only 90. 90 is used while counting. Okay. Now what I have done is I have put negative sign to it. So it becomes minus 90. And we know that negative of the number which is used for counting is an integer. So it is an integer number. Now we take one more example. Minus 9.8. Since it has point in it, this is not an integer. Now you see minus 98. This is an integer. Why? Because this is a number which is used for counting, and now we have put negative to this number. This is an integer. Now again we see 9.8. It has point in it. So this is not an integer. Now we see 56,580. This is a large number. Okay. But you see, if you count continuously, if you keep counting continuously, then you will find this number while counting. So this number is used while counting. So this is an integer. Now you see minus 0.5. Again this number contains a point in it. So it is not an integer. Again you see a point is there in it. So this is not an integer. Now you see 50. 50 is used while counting. So this is a integer. Now you see minus 8,000. If I hide it, if I hide this minus sign, now you see 8,000. 8,000 is used while counting. And we have put negative sign to this number. So we know that negative of number which are used for counting is an integer. So this is an integer. I hope you have understood integers. You can also learn what are whole numbers and what are natural numbers in my other videos at Skill ASC channel. Thanks for watching.
Introduction. Students, look at these numbers. These are the whole numbers. Now look at these numbers. These are the negative numbers. But what do we call a bigger collection of numbers which contains whole numbers and negative numbers? Those numbers are called integers. Come, let's learn more about integers. Objectives. At the end of this lesson, you will be able to define integers, write the properties of integers, and write the operations on integers. Students, what do we get if we add two integers? Let us see. Rohan has 6 balls. His friend Sohan has 5 balls. So how many balls are there in total? Yes, 11 balls in total. From this example, we can say that addition of two integers is also an integer. We can see that addition of integers gives integers. So, integers are closed under addition. Look at Reena. She has 5 chocolates. If she gives 3 chocolates to her brother, then how many chocolates are left with Reena? Yes, you're right. She is left with 2 chocolates. In this example, we see that difference of two integers is also an integer. Hence, integers are closed under subtraction. In general, for any two integers a and b, a plus b is an integer. Similarly, if a and b are two integers, then a minus b is also an integer. Let's now move towards another property, that is commutative property. This is a 10 rupee note. If we add one coin of 2 rupees in it, we will get 12 rupees. Now take a coin of 2 rupee and add one note of 10 rupee in it. Again, we will get 12 rupees. Or we can write it as 10 plus 2 is equal to 12. And 2 plus 10 equals 12. In both the cases, we get the same answer. This means the integers can be added in any manner. Hence, addition is commutative for integers. In general, for any two integers a and b, we can say a plus b is equal to b plus a. When we add 0 to any whole number, we get the same whole number. 0 is an additive identity for whole numbers. Similarly, if we add 0 to any integer, we get the same integer. In general, for any integer a plus 0 is equal to a, which equals 0 plus a. We know that multiplication of whole numbers is repeated addition. For example, 2 plus 2 plus 2 is equal to 3 into 2, which equals 6. Similarly, multiplication of integers is also repeated addition. For example, minus 5 plus minus 5 plus minus 5 is equal to 3 into minus 5. Therefore, 3 into minus 5 is equal to minus 15. Let's now find the product of a positive and a negative integer. Firstly, multiply 6 by 4 and then put minus sign before the product obtained. We get minus 24. Similarly, 5 into minus 4 is equal to minus 5 into 4, which equals minus 20. The product of two negative integers is a positive integer. We multiply the two negative integers as whole numbers. In general, for any two positive integers a and b, minus a into minus b is equal to a into b. Look at these examples. In the first example, two negative integers are multiplied. In the second example, three negative integers are multiplied. In the third example, four negative integers are multiplied. And in the fourth example, five negative integers are multiplied. From these products, we observe that the product of two negative integers is a positive integer. The product of three negative integers is a negative integer. The product of four negative integers is a positive integer. We can see that in first and third examples, the number of negative integers that are multiplied are even, 2 and 4 respectively, and the product obtained in 1 and 3 are positive integers. And the number of negative integers that are multiplied in 2 and 4 are odd, and the products obtained in 2 and 4 are negative integers. Hence, we can say that if the number of negative integers in a product is even, then the product is a positive integer. And if the number of negative integers in a product is odd, then the product is a negative integer. The product of two integers is again an integer. For example, minus 20 into minus 5 is equal to 100. Minus 15 into 17 is equal to minus 255. So we can say that integers are closed under multiplication. In general, a into b is an integer for all integers a and b. Now observe this example. We can say that 3 into minus 4 is equal to minus 4 into 3. Therefore, multiplication is commutative for integers. In general, for any two integers a and b, a into b is equal to b into a. The product of a negative integer and 0 is 0. For example, minus 3 into 0 equals 0. 0 into minus 4 equals 0. Minus 5 into 0 is equal to 0. 0 into minus 6 is equal to 0. In general, for any integer a into 0 is equal to 0 into a, which equals 0. When we multiply 1 with any integer, we get the same integer. For example, minus 3 into 1 is equal to minus 3. 1 into 5 is equal to 5. That means 1 is the multiplicative identity for integers. In general, for any integer a, we have a into 1 is equal to 1 into a, which equals a. But when we multiply any integer with minus 1, we get additive inverse of the integer. In these examples, minus 3 has become 3, minus 6 has become 6, 13 has become minus 13, and minus 25 has become 25. The product of three integers does not depend upon the grouping of integers, and this is called the associative property for multiplication of integers. For any three integers a, b, and c, a into b into c is equal to a into b into c. For example, 7 into minus 6 into minus 4 is equal to 7 into minus 6 into minus 4. Now let us move towards the distributive property of multiplication. For any integers a, b, and c, a into b plus c is equal to a into b plus a into c. For example, minus 2 into 3 plus 5 is equal to minus 2 into 3 plus minus 2 into 8. Similarly, for any three integers a, b, and c, a into b minus c is equal to a into b minus a into c. For example, 4 into 3 minus 8 is equal to 4 into 3 minus 4 into 8. We know that division is the inverse operation of multiplication. Since 3 into 5 is equal to 15, so 15 divided by 5 is equal to 3, and 15 divided by 3 is equal to 5. When we divide a negative integer by a positive integer, we divide them as whole numbers and then put a minus sign before the quotient. Thus, we get a negative integer. In general, for any two positive integers a and b, a divided by minus b is equal to minus a divided by b, where b is not equal to 0. When we divide a negative integer by a negative integer, we first divide them as whole numbers and then put a positive sign. In general, for any two integers a and b, minus a divided by minus b is equal to a divided by b, where b is not equal to 0. Division is not commutative for integers. For example, minus 8 divided by minus 4 is not equal to minus 4 divided by minus 8. Any integer divided by 0 is meaningless, and 0 divided by an integer other than 0 is equal to 0. Any integer divided by 1 gives the same integer. For example, minus 8 divided by 1 is equal to minus 8. Minus 11 divided by 1 is equal to minus 11. But if any integer is divided by minus 1, it does not give the same integer. For example, minus 8 divided by minus 1 is equal to 8. 11 divided by minus 1 is equal to minus 11. Summary. Let us summarize what we have learned. Integers are a bigger collection of numbers which is formed by whole numbers and their negatives. If a and b are any integers, then a plus b and a minus b are again integers. If a and b are any integers, then a plus b is equal to b plus a for all integers a and b. If a and b are any integers, then a plus b plus c is equal to a plus b plus c for all integers a, b, and c. Integer 0 is the identity under addition. That is, a plus 0 is equal to 0 plus a, which equals a for any integer a. Product of a positive and a negative integer is a negative integer, whereas the product of two negative integers is a positive integer. Product of even number of negative integers is positive, whereas the product of odd number of negative integers is negative. If a and b are any integers, then a into b is an integer. If a and b are any integers, then a into b is equal to b into a. The integer 1 is the identity under multiplication, that is, 1 into a is equal to a into 1 for any integer a. If a, b and c are any integers, then a into b into c is equal to a into b into c. If a, b and c are any integers, a into b plus c is equal to a into b plus a into c for any three integers a, b and c. When a positive integer is divided by a negative integer, the quotient obtained is a negative integer and vice versa. Division of a negative integer by another negative integer gives a positive integer as quotient. For any integer a, we have a divided by 0 is not defined, and a divided by 1 is equal to a.